Hi everyone. In this video we're going to look at a few more applications of linear equations. In this video we'll look at systems of linear equations. So here's our first example. This is from Math in Our World. It's on page 394. A tour company in Chicago charges $38 for adults to take its famous architectural boat tour, and I hear it's worth every penny. The price for kids is $22. An evening cruise with 92 passengers brought in $3,160 in ticket fares. How many kids and how many adults took the cruise? Okay, so the first thing is to figure out how we can use equations to solve this. So to do that, we need to figure out what the variables are. And because I have two unknowns here, we need to know how many kids and how many adults took the cruise. That's my clue as to how many equations I need to figure this out. All right, so we have two unknown things, so we're going to need two equations. So let me make a little key, and I'll use an X and Y, but you could also use really any letter that you like, so maybe you like K for kids and A for adults. Okay, but I'm going to use X to represent kids and Y to represent the number of adults. Okay, and X is number of kids. Alright, so what I want to do is try to write two equations that each have an X and a Y in them, and then that will be enough information to figure this out. So let's look through at some of the numbers that we're given. We have $38 for adults. Okay, we have a kid's price, $22. We know there were 92 passengers, and we know that there was a total of $3,160 in ticket fares. So it looks like we have some prices, and then we have this 92 passengers, which is a number of people. Okay, so notice the connection. We're supposed to solve for the number of people, kids and adults. Okay, and we have 92, which is the total number of people. Okay, then we have these prices. So usually if you have two types of numbers like this, that's another clue. So let's try to write one equation that represents the dollar amount of the tickets, and then we'll try to write a second equation that represents the number of people. Okay, so let's start out with the number of people. This one's a little bit easier. We have kids and adults, and it seems like those are just the two categories for everybody going on this tour. So basically we're saying the sum of the kids and the adults is 92, or in other words, the number of kids plus the number of adults, X plus Y, equals 92. All right. The number of tickets. This one, we do want to write this in terms of dollar amounts, but what we actually have are dollars for kids and dollars for adults. All right. So we need to figure out, how to get these variables in here, and this is going to be one of those standard form type equations. Okay, so we've got standard form like ax plus by equals c. Okay, and I think you'll see this in a minute. So let's try this. Let's just pick a random number to start with for the kids and the adults. All right, so we know there are 92 of them, so let's just take a guess, and let's say that there are 90 kids and 2 adults. Heaven forbid. That would be probably a pretty chaotic tour. But if that were the case, then how would we go about finding the dollar amount for the tickets? All right, well, if it's $22 per kid, then what I would do is take that $22 per kid, I'd multiply that times my 90 kids, okay, and I'm going to add in the cost of the adults. I would be adding in $38 per adult. All right, so times 2, and then I would work that all out, and I would get a total amount. So let me quickly do that. All right, and I get 2,056. All right, so I know that's the wrong number, okay, because it was supposed to bring in 3,160, but this does give me sort of a format for the equation. Okay, I'm going to take $22 and multiply by the number of kids. Now, instead of just taking a guess that there were 90, instead to write the equation, I'm just going to leave that as a variable. There are X kids. And then I'm going to add to that the cost for the adults, $38 per adult. And instead of guessing that there are 2 adults, I'm just going to leave that as a Y. And now instead of working out my fake numbers that I picked to get the total, instead I'm just going to record what I knew the total was. We know for sure that there were $3,160 in ticket fares. And basically that gives me the equation that I want. Alright, so we have, and I'll skip the units now with the dollar symbols. Okay, so we have 22x plus 38y equals 3,160. Okay, so now we have a system of equations, and now the goal is to try to solve this. I want to find the correct number of kids and adults so that it adds up to 92, and so that I end up with the correct amount for the ticket fares. Well, how do we solve this? This is something we've already talked about. We've talked about elimination or substitution as 2 algebraic methods to solve this. So I'm noticing that first of all, these coefficients are rather large, so I probably don't want to use elimination. I'd have to multiply this second equation by either 22 or 38. And instead, maybe what I want to try is substitution. So I'm going to rewrite this second equation. Okay, I'll solve this for either x or y, and I'll choose x. Alright, so I would subtract y from both sides and get x equals 92 minus y. And then I'm going to substitute that into the first equation in place of x. Okay, so I've rewritten that, and now I just need to use the distributive property and start simplifying this, okay, and try to solve for y. So let's see, 22 times 92 is 2,024, okay, minus 22 times y, plus 38y equals 3,160. I can combine the y's. So negative 22y plus 38y is 16y. Okay, and then I can start solving. So that's as simplified as it gets. Okay, so I wanted to subtract 2024 from both sides, and that gives me 16y equals 1,136, and then divide both sides by 16, and we get y equals 71. Okay, and then substitute that back in to one of the previous equations. So I've got this one, I know x equals 92 minus y, so x equals 92 minus 71, or x equals 21. So there were 21 kids and 71 adults. Okay, now as a double check, first of all, I know that this adds up to 92, so this checks out with that piece of information. Now to check for the ticket fares, I just want to go back and use those specific numbers to test what I initially did. All right, when I just made up some numbers to see if those were correct. Okay, so I want to do $22 per kid times the 21 kids, and then $38 per adult times 71 adults, and check and see if that does equal 3,160. So I'll leave that for you to check. All right, let's do a second example, and this is the last one we'll do. You are baking a cake which calls for 50 grams of chocolate, which is 70% cacao. You have 200 grams of 59% chocolate and 400 grams of 100% chocolate available, but none with a 70% cacao content. So this is actually a problem that I wrote based on a real situation in which I did use algebra. I was actually baking a cake, and I did need this correct amount of chocolate. Okay, I needed a cake which called for 70%, like that amount of sweetness. If you're not familiar with cacao, basically what we have for chocolate is like a chocolate bar is a combination of pure cacao and then usually sugar and maybe some other things like flavoring or things like that to kind of hold everything together. So basically, just this percent of cacao is versus the sugar kind of describes how sweet the chocolate is. So like a milk chocolate would be less cacao and more sugar, so like the 40 to 50 range, and then 70% is like a real dark chocolate, and then 100% is an unsweetened chocolate. So I basically needed to mix these two, use what I had on hand to end up with the appropriate amount of sweetness for this cake. Alright, so here's the two unknowns. I don't know how many grams, and this was a recipe from a blog in a different language with grams instead of ounces. Okay, so that's hence the units. So I needed to know how many grams of this 59% chocolate bar and how many grams of the 100% one I should mix to get the appropriate amount of 70% chocolate. Okay, so fortunately I had a scale on hand to measure this and weigh this all out and get the correct amount. Alright, so let's call these variables x and y, and I'll have x be the 59% chocolate bar and y be the unsweetened one, the 100% chocolate or cacao bar. Alright, and I'm going to mix the two to get an amount that's 70% chocolate. Okay, so how many grams of each? Okay, and I guess let me record that here. This is actually grams of the 59% bar and grams of the 100% bar. Alright, so we have two things here. We have I need to make sure that the grams are correct. Okay, well, how many grams are needed for the cake? If you sort through this, okay, it's actually given in the first sentence there. I need 50 grams of chocolate altogether. So I need an equation that says that the one type of chocolate bar plus the other type of chocolate bar adds up to 50 grams. Okay. And then the second equation, I need to make sure that it has the right sweetness, the right cacao content. So I can write a second equation to describe that. Alright, well, let's start with the grams. Okay, so these are the two unknowns, and I have some extra information here. I have 200 grams available of the 59% chocolate. Basically, I have, and 400 of the other one. So basically, I have more than enough of either type available. I just need to get the correct combination. So this is extraneous information. And actually, I don't know how much to use of each one. So I'm going to leave this as x plus y. Okay, grams of one plus grams of the other. So for the second equation, I'm going to work with percentages here. And to get the right cacao content, okay, I'm adding up 2 from the chocolate that I have. And I want to make sure that I end up with 70% chocolate. Okay, well, 70% of what? Well, it's going to be 50 grams altogether. So here we've got percentages, all right, so I'm taking 70% of the 50 grams, okay, and that's going to give me the cacao content for that total amount. All right, so just a reminder when you're working with percentages, to take 70% of something, you can multiply by that percent as a decimal. 70% is 0.70. Okay, so 70% of 50 grams is 35, so more than half of that, okay, 70%, is going to be that pure cacao content, and then the rest is sugar and all the other stuff in that chocolate bar. Alright, what about the cacao content from the two types of chocolate that I have? Alright, well, I have a 59%, so whatever the grams are for that one, I know that 59% of those grams, okay, or multiplying, that's the cacao content. And then for the 100%, okay, that's 100% as a decimal is just 1, so the whole thing, all the grams from that chocolate bar are that pure cacao. Alright, so here I have another example, and notice it's still the same format as the last problem we used. It's this ax plus by equals c. So we have basically two coefficients that are associated with two parts, and we're adding up to a whole constant number. Okay, so in this case my coefficients are percentages. I have a percent of one thing plus a percent of the other equals a percent of the total. Alright, so those are the two equations, and let me just simplify this a little bit. I'm going to write this, just cleaned up a little bit. Okay, I'm just getting ready to solve here. So we have x plus y equals 50. And then I have 0.59x plus y equals 35. Okay, now this is another system of equations, and we could use substitution or elimination. I reviewed substitution in the last example, so I'll use elimination here. And the y's already have, the same coefficient, a 1. So what I really just need is for one of them to be a negative sign. Alright, so I'm going to multiply the second equation by a negative 1. So I'm going to end up with x plus y equals 50 still. But the second one is going to be minus 0.59x minus y equals negative 35. Okay, so now when I add, this is like a 1x plus negative 0.59, and that's going to be 0.41x. Then the y's, I have 1y minus y, and that's 0, so that's like plus 0, or we don't even have to write that. And then 50 minus 35 is 15. Okay, so now I need to solve for x, so I want to divide both sides by 0.41. And we get x is, and this is an approximate answer, 36.59. Okay, so x was the grams of the 59% chocolate. Alright, so I probably would just round that. My scale goes to the nearest, I think it's the nearest gram. Alright, so if it were me, I would probably just round that to 37 grams of the 59%. Okay, and then which equation do I want to substitute this into to find y? Well, I think the first one's easy. I know that the sum of the two chocolates has to add up to 50. So then if I substitute 37 in place for the x, okay, then I know that, then I basically just need to subtract 37 from 50 to find y, the grams of 100% chocolate. Okay, so subtract 37. And then y equals 13 grams. 13 grams of 100%. Alright, that's it for this video. So we've looked at just two applications of linear equations, and the main thing I want you to get from this is if you see two different unknowns, okay, like we asked how many kids and how many adults, or in this case how many grams of two types of chocolate, okay, that's a clue as to how many equations you need to write, and then we can go from there. Okay, the other piece is just deciding, should we write y equals mx plus b, or should we use standard form? Okay, ax plus by equals c. And then from there, it's reviewing things that we've already talked about, solving by substitution or elimination. Okay, thank you for watching.